really do with the slide advancing. Ah, here we go. There we go. The obligatory about me. So I'm the software development manager at a company called Interact Internet. We build massive, well, sorry, not massive intranets, but we build intranets for some big people like the Co-op and PlayStation and Waterstones and people like that, big enterprise companies. I've got to mention that we're currently hiring developers. If you're interested or looking, please get in touch with me and you can come join my team. I'm also on GitHub, Twitter, LinkedIn, and YouTube, so you can find me on there, and my blog at manchesterdeveloper.com. I also have another website, which if you're a .NET developer, you'll probably be interested in, called visualstudiotips.co.uk, so go check that out. And then a lot of the stuff we'll be talking about today is also on a website called xamarinarkit.com that I put. Now, there is another Lee Englestone. If you Google for the Lee Englestone and you find a race car driver, that's not me. I'm not that excited, unfortunately. So I'm the other one, the .NET developer, not the very brave adrenaline junkie this person seems to be. So just to set some expectations, there's going to be a few things we're not going to talk about today. We're not going to be talking about HoloLens other than to show you a picture of me wearing the HoloLens and for some reason not shaving that day. We're not going to be talking about mixed reality toolkit, Unity, virtual reality, AR Core, which is Android's augmented reality framework, or web AR. These are great technologies. You can create some interesting experiences with them. It's just not part of this talk. So what will we be talking about? So we're going to be looking at how .NET developers can create AI experiences without an expensive headset like HoloLens, without using Swift or Objective-C, without using Xcode. Small caveat on that, because you do have to launch Xcode to deliver the certificates to your phone to begin with, but we'll go into that. Without being part of the paid developer program, everything you see that I do in this presentation, it has been done without being part of the paid development program. We're going to be targeting iOS devices specifically using .NET C# and using a Mac and VS for Mac. So let's see what the kind of things are possible we're using those. So as well as looking at some specific use cases for augmented reality that you can see on the right-hand side, image detection, plane detection, body tracking, stuff like that. All this is sort of built out into ARKit and just comes right out of the box, which is really, really handy. We're also going to be looking at the business of AR and specifically how .NET devs can do it. Now, before I get too much further, what I like to do is show some videos of what we're talking about, because I've been to a bunch of these talks and I know that it can get quite dry at the beginning and then it's only see the end result of what we're building. So I just want to flip that on its head and look at some of the examples they're going to be talking about. So I'm just going to jump on over to some videos that I created earlier, if that's all right. So let's have a look at this one. So what we're doing here is I'm showing the periodic table. If it stops buffering, this would be a rubbish time for my internet to go down. Come on. Sure, let's go find another one. Let's go try this video. YouTube's on a go slow today. Kind of YouTube working. Do you know what? I'll skip this bit. Don't know why YouTube was not working today. How bizarre. I presume it's down completely for everyone in the world. Can't just for me. That's bonkers. Right. That's going to make looking at videos later interesting. Let me just try one more. Okay, we seem to have some success with the videos now, so I'm just going to try one more time to play this video. Thank God. Right, here we go. So then here what I'm doing here is showing the periodic table in augmented reality. And what I'm doing is just putting some text or some 2D planes that are a bit opaque and animating them when I touch them on my screen. And you can walk around that and it'll be held stationary in that environment as I walk around it. So that's one thing I've done. That's quite a fun one to do. And you can imagine the additional use cases for that. And then we'll look at one more and then we'll jump into the talk. So here I've got kind of like what I call like a 3D photosphere, which is like just 2D planes with images on them, which is just rotating around me, stood in the middle, and I can look around at these and I can do some interesting things like cast fake shadows onto the floor with a fake light source above. So that was quite an interesting one as well. So this is the kind of things we're looking at in this talk. Hopefully the rest of it goes a bit smoother than that. Okay, now you can also try this at home because what I've done is put a lot of these examples together, packaged them into an app and put it into the iOS store. It's completely free. I've never created an iOS app before. It's quite fun. It's just to show that it is possible to use C# and Xamarin to create our experiences and package them up, put them in the app, and then other people try them. You'll also see quite a lot of use of QR codes in this talk as well. So what I'll do is when you see them, I will try and pause for a few seconds to give people a chance to use them if they want. Otherwise, we'll just be moving on to the next slide. So you have to be quick if you want them. Right. Okay, so the breakdown of this talk is in 3 parts. The first part will go into a bit of the background of AR. So what we're talking about when we talk about AR, just to make sure we're all on the same page. Maybe look at some of the terminology. We're also going to look at the business of AR. So it's all good and well having a nice shiny technology, but what a business is doing to make money out of this. Why are us developers creating apps to take advantage of this technology? And then in part 3, which by far the largest part, we'll be looking at the implementation of some of these use cases. Let's start with part 1. What is AR? So there's quite a lot of definitions of AR. So I didn't like many of them. So I came up with my own and I've settled with it's making something look like it is there that isn't actually there. And I'm quite happy to say that to my mum. If my mum says, Lee, what is augmented reality? It would be a bit unusual to have that sort of conversation, but this is what I would say. It's making something look like it's there that isn't actually there. Now that's not to be confused with virtual reality where you put on a headset and your whole vision's occluded and everything you see is a projection of the running app on the headset. Augmented reality is you can still see the world around you, and but the app running is also just placing things into that scene as well. So it's a mix of the real world and augmented stuff placed in. Okay, so that takes us on to what is ARKit. Now, this is Apple's augmented reality framework, which runs on iOS, and it uses something very, very clever called visual inertial odometry, which I can never explain very well. But what it does is it combines the camera on your phone as you're moving around and looking at it, and this is where I have to refer to my notes. It also uses the motion sensing hardware in there, like the accelerometer, as you move your phone around, and the compass to know which direction you're pointing, as well as a healthy dose of computer vision analysis of the scene to determine points of interest in the scene, so it can remember what parts of the environment look right. So if you put like a fake desk in a place and you move back to it, it'll know the feature points around it, and it knows, oh, you put a desk there, I need to keep it stationary in that sort of location. So ARKit was originally an Apple framework, as I mentioned. Now it was ported to .NET by Xamarin, among other frameworks, so that it could be targeted by .NET developers and use that augmented reality stuff. And we've got a slide on that next, but it's not to be confused with AR Core. Now, AR Core is Apple's equivalent of ARKit. AR Core is, Android. AR Core is Android's augmented reality frameworks. If you want to be developing AR experiences for Android, you wouldn't be using ARKit, you'd be using AR Core or something else. So what is Xamarin then? So originally it was a standalone platform you used so that you could write C# and deploy it to iOS and Android devices. So it's a cross-platform framework. It was acquired by Microsoft in 2016, and now it's rolled into Visual Studio. So you can create applications that will run on Android and Apple devices using C# and .NET. So we are also going to be looking at Xamarin.iOS, not Xamarin.forms in this as well, in this talk as well, as there's sometimes confusion, but they're very, very different things. So we'll be looking at Xamarin.iOS. Now, that kind of concludes part one. I told you it was a short part. So then it takes us on to the second part, which is the business of augmented reality. Now, when I talk about augmented reality with different people, it's usually in one of three camps, and it really polarizes people. And if we take these three examples, like Peter Jones in the top right here, and he's saying, I don't get it. That doesn't make sense. I just don't get it, which is fine. It's fine. You know, some people I don't see what the big deal is. That's fine. Whereas we've got in the bottom left, we've got Deborah Meaden and Peter Jones again saying, oh my God, that's amazing. That's the next best thing. Can you imagine the possibilities? And then somewhere in the middle, you've got another dragon, I believe in the bottom right, is saying, impressive, that's cool, that's neat. I don't know how useful it is, but it's kind of cool. So it does really polarize people when you talk about this stuff. I'm kind of in the camp of, this is going to be big, augmented reality, or I wouldn't be given talk about it, I guess. So now, when people talk about augmented reality, they have to at least mention Pokemon Go, because for me, Pokemon Go was the thing that made me sit up and take notice of augmented reality. This is when AR came of age. So I've never actually played Pokemon Go, I'm going to admit, but I know a lot of people do. So maybe you played it and you've got your own sort of Charmander or Bulbasaur or something like that. Now, it has been a very popular app, but I'm not sure how many people know how successful it was. So I just want to delve into this. So in the first 20 days, it made $100 million. Sorry, that's how much was spent. Oh, it's one of them. This might be what it was made or spent. And then in the first month there, it was 207 million. And then I've got a separate slide on that. So what this proved to me was people are not only enjoying using their phones and moving it around and making things appear that they're there, they're not actually there, they're actually willing to pay for that privilege. And then, so this is the second slide on Pokemon Go. It's not all about Pokemon Go, don't worry. Now, just want to highlight then, over the last 4 years, now this is by user spending, users have spent close to $3 billion just on Pokemon Go. Now, that's a good statistic that kind of shows to me that this AR stuff has got legs, and it's probably going to be around for a bit while longer. It's not just going to disappear overnight. That's a nice payday for the developers as well. But it's not all games and entertainment. We've seen an increasing number of use cases and real-world businesses and bricks and mortar businesses starting to use augmented reality in their products and their business models. So here we can see a lady trying on spectacles on augmented reality, where she can possibly look through hundreds of different frames and see what they look like on a face, or actually having to try them on for real, which, as you can imagine, is quite handy for our lockdown in a global pandemic and we can't travel anywhere and go to the shops. Another use case, which I have tried, so another app I have tried, it is kind of neat, is this app on the App Store called Wanna. What you can do is, I suggest you take your shoes off for this, is you can select a shoe in their catalog, then point it at your feet, and it will look like it will show you what it looks like on your feet, and you can move your foot around, and it looks kind of cool, and it looks like it's for real. So that's quite a neat one as well. If you haven't tried that, if you're a bit unsure about AR, if you try the app, it might convince you that this really is going to really revolutionize the e-commerce industry in lots of use cases. Now, there's not only shoes, I've seen apps where you can try on high-end watches or jewelry as well. So yeah, this is one good use case. We're also seeing an increasing number of manufacturers creating 3D models of their products and allowing you to use your phone to see what it looks like in your environment. And that this includes people like IKEA, where you can place furniture and see what it looks like. This is happening by more and more manufacturers. And what you can see here on this slide is actually from Google website saying, if you create this, the 3D model of your product in a USDZ format, and you put it on your site in a certain way and get it indexed by Google spidering, it will actually show in the Google search results, straight in the search results. If it's here, we can see someone search for coffee maker on the left-hand side, and straight from the search results, you can press a view in 3D button and then view in your space on the next screen, and you can see that coffee maker on a table in your living room. And there's some interesting statistics about the conversion rates when people do this. And I'm sure I've seen a statistic knocking around. I've not got it to hand. I apologize. It's something like if someone is using AR to view a product in their environment, something like the conversion rate is like over 1,000%, something ridiculous. They're a lot more likely to convert if they can see it. But it's not just coffee makes happen for like Burberry handbags and stuff like that. Now, so far we've talked about augmented reality on our phones. So when we wave our phone around and making things appear that aren't actually there. But for me, the game changer of the next revolution of augmented reality is when these augmented reality glasses hit the market. And these have been sort of promised for years and years and years, but I can see an increasing number of manufacturers all sort of scrabbling to be first to market and to get market share on this. And they're getting really, really close. They're still a bit expensive, some of them. But I think this is going to be when things do take off, and it was going to be the thing that moves us away from being hooked to our little black screens, either our monitors or our laptops or our black phones, and just staring at our black screens for information. This is going to be how we consume information in the future. I do truly believe that. And it's going to be software developers like us that are building interfaces for these sort of devices. And it's going to be not very far in the future that you can see more job adverts say wanted augmented reality interface designer, for example. Have I got any more on that? Yeah, the last thing I'll say on this is that the version 1s of these might not be very good. So you go back to thinking about what the version 1 of the iPhone was like. It looks a bit like something that belongs in a museum now, but at the time it was pretty revolutionary. So whilst the version 1s of these devices may not be amazing, the version 2s, the version 3s, the version 4s are going to be amazing. Okay, and then this is sort of my little equation that I put together, very simple one really, that is kind of the make or break of the success of augmented reality. And if we just break it to customers, people don't spend $3 billion on something if we don't have the customer share to the win to do it. We have the software that allows developers and businesses to create these experiences. We have ARKit, we have AR Core, we have Unity, we've got Facebook have even got their own framework called Spark AR. I think there's one called Vuforia. There's a few of these that sort of spring up. Businesses are slowly starting to wake up and take notice. People like IKEA, the shoe people, quite a few others. But the thing that's really gonna is slowing things down a bit, and is the missing part of the equation, is this hardware. We've got them on our phones right now, but I think once the glasses hit the market, this is when the Wonga is going to be there, and the market's going to be ripe for taking advantage of. So that concludes part 2 of the talk. So that was your intro to augmented reality. Hopefully we're on the same page, and we're all kind of know what I'm talking about now. So next, this part is where we pop the hood and look at the implementation. How do we create these sort of experiences that we've just talked about? Okay. So when you're starting out and you want to create AR experiences using Xamarin and C#, you will need a MacBook, because there's no way at the moment for building apps without creating apps without compiling them on Apple devices, okay? So you don't need a paid Apple developer account, you just need an Apple ID, and you can sign up for them for free. Most people generally already have them, especially if they're already in the iOS ecosphere and you've got iOS devices. So like I said earlier, you will need to initially create the project in Xcode and deploy it to your device initially. And what that does, it will create the code signing certificates and deploy it to your device. Now, once you have done that and you get the bundle ID, which is like the ID of the app, you need to take a note of that because you're going to reuse that. And then when you can create the app again in Visual Studio and reuse that bundle ID, from there on in, you can just reuse, from there on in, you can create you just write C# to create these experiences. Okay. So on the left here, we can see there's a screenshot of what you'll have to choose in Xcode for the first time. The reason I mention it is that you want to choose this single view app. You don't want to use this augmented reality app for the way that I'm trying to explain. Now, I'll just caveat that I'm sure there's multiple ways of creating AI experiences on Apple devices. This is just one that I found that sort of works for me. And then when you come to Visual Studio for Mac, you'll be wanting to create this iOS app area and then choosing again single view app and then reusing that bundle ID that I mentioned. So that's how you get it initially set up. And I appreciate that I've glossed over a lot of that, but I didn't want to go into too much detail. Then what we need to talk about before go much further is talk about SceneKit, because as well as ARKit, which is the augmented reality framework that Apple has, the SceneKit. Now, this is their 3D graphics framework, and this was around for a long time before ARKit ever came onto the scenes, and this is what people used to create games on iOS devices, and what you can use heavily in ARKit to add things into your AR scene. So we'll be using this a lot in the examples to come. And it's quite cool because it also has a built-in physics engine and particle generator, although I've never used a particle generator. But the next slide shows just how much we do borrow from SceneKit to create these experiences. So everything in green here, we get from SceneKit, I believe, and you can usually tell because it's prefixed with SCN, and everything in blue comes from ARKit, and you can tell because it's prefixed with AR. It's pretty easy to remember. I didn't create this slide. This is from a chap called Ryan Davis, so creds to Ryan. Thanks. He's very good at create slides for me. We're going to talk about some of these things. We're going to talk about anchors later on. We're going to talk about these scene actions, which I call animations. These geometries here, which are like our primitive shapes that we'll be using in the scenes. And we'll be talking about session and the scene as well. Oh, as well as these other stuff like tracking images and face tracking and stuff like that. Okay, so the magic part, some of this does feel like magic sometimes, that makes this all work, and we'll look at this in the code in a bit, is this scene view class. And what that does is, again, this is quite difficult to explain, but this combines your camera feed, puts it as the canvas of your app when you're looking at it, but it also allows you to place 3D items, augmented reality items into that scene once the AR session is running. Yeah, it's hard to explain. So when the AR session's running and the camera's showing the feed what it's seeing onto the canvas of your app, and you're adding things in there, it's using invisible anchors that, unbeknownst to you, to map its surroundings. And what it's doing is picking out feature points in that scene. And the accuracy and the ability of that app to figure out its surroundings relies on a few things. And one of those is light. If you're in a dark space, it really struggles to pick out feature points in that scene. So if you try and place a 3D model in that scene, and it's not got enough light, for example, it can't keep track of its surroundings and it might just move around. Whereas if you've got lots of light, it'll be able to keep that item stationary in relation to its surroundings. Other things that are going to affect its ability to track are things like reflective materials like glass or mirrors, and surfaces that have got no detail in. So things like a white wall. If it's looking at a white wall, it's very difficult to pick out feature points to keep things in relation to, if that makes sense. We're going to look at anchors in a bit. These are points of interest in the scene, and you can manually place them, or you can more commonly, if it detects an image in the scene you've told it to detect, it will place an image anchor there. If it detects a plane, a flat surface, it will place a plane anchor there, and similar if it detects a face, it will detect a face anchor, and it knows to keep tracking at that, and that allows us to do some interesting things with those anchors. Now, this is where it starts to get interesting. So the 3D coordinate system is quite an easy one to get script with. It's very similar to no other coordinate systems, similar to ones you probably learned in school, where Y is up and down, X is left to right. So if you want to go to the left or place an item to your left, you need to set its X value to be minus, and to the right positive. And if you want to go front to back, you need to use the Z index, but there is a gotcha with the Z index I have to explain. Notice that its minus is in front of you and positive is behind you, which got me for ages, because when I was first experimenting with this stuff, I thought, right, I'm going to place this sphere a meter in front of me. So I'm going to put it 1F, which is, you can see here, the sizes are in floating point data types, where 1F equates to 1 meter, pretty easy to remember, and therefore a tenth of that is 10 centimeters and a tenth of that is 1 centimeters. But going back to the Z index, I thought, right, I'll set the position of this sphere, its Z property, to be positive 1F. That should be 1 meter in front of me. When actually it placed it a meter behind me, because positive of Z is behind me. And it took me ages, an embarrassing amount of time to figure out. I was saying to myself, where on earth is this sphere? It should be a meter in front of me. It wasn't until I sort of had a good glance around the whole room and found out it was actually behind me. So just one little gotcha. If you want to put something in front of you, you need to use the negative Z, not the plus Z. Otherwise, you'll be banging your head for a long time like I was. The other point to mention is that wherever your app was when the session started, it is 0, 0, 0 in the coordinate system, otherwise known as the world axis. So if you place an item into the scene and you don't explicitly set its X, Y, Z coordinates, it will place it at 0, 0, 0, which is exactly where you're standing. So if you want to see it, you have to actually move backwards to see it, if that makes sense, and not be in front of you. Okay, now scene nodes, this is a class, and these, I like to refer to these as like the building blocks of all the augmented reality experiences I've created. So a scene node, you can set the shape of it. So you can set its geometry, and that's how we set it. Say it look like a sphere, looks like a 2D plane, look like a cube, look like a cylinder. We'll go into geometries in a second. We can give it a material as well. So we can say, make it red, can make it blue, make it transparent or opaque, or even give it an image to render an image on that object. And we can also give it some physics properties as well. We can give it some mass. We can say, give it a solid skeleton, so other things with solid skeletons can bump into it, or we can say, make it be affected by gravity, so it's just pulled down until it hits something else solid. So in many ways, they are just like Lego bricks, because one Lego brick by itself isn't very interesting, but they all have a certain color, a certain shape, a certain use, and it's not until you start putting more and more of them together that they start becoming something interesting. So those are the building blocks of ARKit. I'm going to skip over the code sample for this, because we'll come in later code samples. We will actually see a lot of use of seed nodes. Now, geometries we mentioned, we've got some built-in geometries we can use right out the box. So from left to right, we can use boxes, not cubes, boxes, because a cube is always the same width, length, height, whereas this is a box, so we can have it a very flat and wide, or tall and narrow, just like an Amazon package rather than a dice. So that's a box. Then we've got this one here that looks like a tablet called a capsule. Then we have got a cone. I've never ever used some of these. Then we've got a cylinder, a 2D, sorry, that's just called a plane. I do use them an awful lot, very useful. Pyramid, again, I've never used a pyramid. Sphere, which are only really useful if you want to make something that looks like a planet or a snowman. And then this donut shape here is called a torus, and then we've got a tube. So that's cylinder. This is tube here, which has got like a hole in the middle. And you can set some of these properties. So you can set the radius of this, or the width of these toruses, or the radius of this hole in the middle. And then there's another one that I always forget, which is hiding in plain sight, which is this one here called scene text. But I don't tend to use that because it's a bit fiddly to use, I find. It doesn't really look very good when I place them in the scenes. So what we'll do is we will look at geometry code because it's might be interesting. Okay, so I can find it. Geometry shapes. Okay, so I've zoomed in as much as I can without going mad, just so that hopefully the text on your side is quite visible and not teeny weeny. So we've got this controller here, which inherits from UI. Ooh, it's a lot of documentation. Inherits from a UI view controller. We have this magic AR scene view, which allows all the magic to happen. And then we're in this controller for this class, we're instantiating the scene view. And this sort of boilerplate code, which you'll see reused over and over and over again in all the other examples. And I won't go say what every line does in every example, but I will go into a bit of detail on this one. And then you can set some properties of the scene view. And then you're adding the scene view as a subview of this view. And then in the view did load, we seem to be setting the scene views frame to be this view's frame. So I imagine this is setting, again, the canvas of the app to be the feed from the camera. Then I'll just come back to this method in a second. Now, when the view did appear, what we're saying is I want you to start running this scene view session with this tracking configuration. Now, we're going to look at different tracking configurations in the talk. We're going to look at face tracking, image tracking, I think, but this is your bog standard normal one. We don't need to talk about these just yet. I'm setting a 0.05f, which if you were paying attention earlier, you'll know is 5 centimeters. Yep. And then a Z position of minus 0.4, which should be 40 centimeters in front of us. Notice the minus at the front. So here are these Lego brick classes, these scene nodes. And you'll notice that I've got a box node, a sphere node, and torus node. They all initially start life as this seed node. And then what I'm doing is I'm setting the geometry, which is the shape of these nodes. And I'm using these static methods here. So scene box.create, sphere, scene sphere create, torus create, and I'm setting some parameters which are all different depending on the shape you want to create. Length, width, height, something like radius, and that's something like ring radius and pipe radius. And then what we're doing is we're setting these materials to say, well, okay, so at this point, you're not going to see anything. So we're actually setting the materials. And in this case, we are setting the material to be, calling a method, and we're saying, passing in a value of red, instantiating this scene material, and setting the color to be the color we're passing in, and then we're returning the material. And then, so at this point, we've got the shape, its color. All we need to do now is set its position. So we do this using instantiating a scene vector, and we just pass it X, Y, Z coordinates. So here we've got 0x, which means don't go left and right, 0y, so don't go up and down, but Z, put 40 centimeters in front of us. And again, we'll just put these in different places. So then at the end, what we're doing is saying add these nodes as child nodes to the root node of the scene view. And then once you're used to that code, you can just start putting anything in there really. Some more boilerplate code there. And then when that runs, you will see a number of basic shapes all in a line, similar to this video, that video here, but I'm not going to show it. Okay, so then that's the first bit of code done. Now, animations, or more specifically scene actions, but I call them animations because usually I'm animating something when I use it. Now, tip number one, things look more interested when they're moving. When you place static things in the scene, it's a bit boring. So when you start introducing some sort of movement to it, it does get a bit more interesting. And you can animate a whole bunch of things. You can animate things like an item's opacity, so you can fade it in or fade it out. You can animate its scale to make it grow or shrink. You can animate its location, so move it from left to right or any position to another position. And you can also turn it to rotate and animate that. Now you can also group these animations, so you can do them you can group them so they're done either simultaneously or one after another. So you might fade something in and make it move towards you and make it enlarge at the same time. Or if you could sequence them, so you might say fade in, then move to here, then get bigger. So there's ARKit, sorry, I've got to be careful because I always say ARKit, this just comes from SceneKit. SceneKit makes it really useful to make these interesting movements. You can also get these animations to repeat either once or indefinitely or X number of times. So once, twice, 10 times if you want. And you can also ease these animations. So thing about movement is it can be a bit jarring if it just starts and stops. So if you think about a car, if a car moves anywhere, it accelerates from a standstill to the speed it wants to go, and then it slows down to a standstill. You know, a car doesn't go from 0 to 60 and then go from 60 to 0. There's an acceleration time, and then a deceleration time. So that allows us to use easing in our animation. So rather than just going left to right really quickly, it can just like start moving, get a bit quicker, then slow down before it stops. I think I've explained that okay. So let's look at our first example of animations. So again, a couple of QR codes here. These will just take you to the videos on YouTube. Now, the other reason that I show these QR codes is because sometimes when I'm showing the videos or animations, when I'm presenting like this, they can look really staggered or jittery, and that's not true in real life. These are really hate anyone to get the wrong impression and think, oh, this augmented reality or the animation's really jagged. It's not, but if you look at the videos, then hopefully you'll be able to see some proof of that. So let's look at the rotating world animation one. Come on, YouTube, are you gonna play ball? Right, so here we've just got a sphere, and I've given it a material of a 2D image, just like a JPEG or something. And then I'm saying use a scene action or an animation to rotate 360 degrees over, I think, about 5 seconds. And I've also got like, I think it's something like 95% opacity. So it's 95% opaque. So there's about 5% transparency. So this is tip number 2. If you make things look transparent, it makes things look cooler as well. It makes futuristic as well, I think. So yeah, so that is animations. And then we looked at this one briefly as well at the beginning. This is combining, how you can combine animations. So I'm combining opacity, movement, and scale as well. I have no idea what's up with YouTube today. Here we go. So hopefully this is the one where I touch them and they move. It's not, is it? It's not wrong video. This one near the willow tree. I could tell this wasn't recorded anytime soon. Weather looks nice. Yeah, so I'm combining sort of fading in, I'm combining movement, and I think there was a tiny bit of scale going on as well. So yeah, and then when you touch them again, I'm animating the movement. So that is animations or scene actions, depending on what you want to call them. So the next interesting thing we can do, which is right out the box of ARKit, is plane detection. So you can get it to detect horizontal planes, like a floor or a tabletop or surface, or walls, the walls around you. And you might think, well, why would you want to do that? Well, I know a number of businesses that have got apps that allow you to see what posters look like on your wall, or what wallpaper or paint looks like on your wall before you even sort of buy it and try it out. So there is certainly business applications for this sort of stuff. It's also good because when we can detect surfaces, it allows us to define sort of the constrictions of where we might want to do other things. So might want to use physics and bounce a wall against the wall or the floor, or drop something onto the floor, or place an object onto the floor. We need to detect the floor to be able to do that in the first place. Now, an interesting thing you'll see in this next video is that as you launch your camera, it kind of makes sense if you think about it. As you move your camera around, the more of your environment it sees, the better it can understand its environment. So it'll start off by detecting a section of the floor or the wall. And when you move around and show the camera more of the wall or the floor, it increases its understanding, and it will start increasing the size of that plane. And as I mentioned, it drops these AR plane anchors when detected. And then at that point, that's kind of like an event. And we can hook into that and say, okay, you're placing a plane here. Is it a floor? Right, let's make it blue. Is it a wall? Let's make it red. I've got a video for that as well. You'll also see how the number of feature points is important in its ability to detect and react to its environment. So let's have a look at that video. See this one? No, it's not that one. Would have been an early one. This is it. Right, okay, so if you see any yellow dots, you can turn on this mode that says like show debug the feature points. So you can see where there's an interesting items, like this poster, for example, there's lots and lots and lots of feature points. So it can understand, you can better remember that there's something there. Whereas on this plain white wall here, you can see that there's no feature points. So that it really struggles to understand what kind of is. So eventually as I move around, my study at home, and it also got not very good lighting in here, so this is also affecting the app's ability to understand its environment. It will start saying, all right, okay, this floor is a bit bigger than I originally thought, or this wall's a bit bigger, and eventually it does, I'll just try and skip on a bit, it will eventually sort of detect all these sort of surfaces. So that's plane detection. Okay, so the next interesting use case is image detection. So this is interesting. So you can get it to detect up to 100 different images. So by that, I mean you could bundle 100 different images along with your app and give them like each a name or an ID. And then as you're moving your app around the scene, if it detects one of the images, it will like fire an event, and you'll be able to, that it will tell you the exact location that image was found, and also which of those images. So we can do some interesting things with that, which we'll see in a minute. So as well as bundling 100 different images, you can also dynamically add images to detect. And you might think, well, why would you want to do that? Well, you might not know what image you want to detect at compile time and when you're deploying your app. So one use case for this might be, for example, maybe when your app loads, maybe you're in a bookshop, and when the app loads, it goes off and hits the Amazon API and gives me the 100 best-selling non-fiction books, gets all the front covers for those 100 books, and then puts them in memory. And then as you're moving around the bookshop and you wave it over one of the book covers, and it detects which, it will detect that book. And then because you know which book it is you're after, you might be able to also have the ISBN number along with the app, or that first API call. You might then go hit the API call, Amazon API again, and say, right, go get me the reviews for that book, and show the reviews for that book in augmented reality around the book. So that'd be quite a neat use case. Now, for some of this stuff, you do have to use your imagination. If you've not got that much of an imagination, AR might not be for you. But if you do have a good imagination, you should sort of instantly be thinking, oh gosh, I could use it for this. Or it's really amazing when you start really thinking what the kind of things you could do with this stuff. Now, image detection. I've got some videos. What's the first one? Add images to detected image. So here, I have packaged an image that's just my business card to the app, and when it detects it, it knows the location, and all I'm doing is like 6 other images to that image anchor. This headshot to the left, these social media icons to the bottom, and then these 2 transparent PNGs. Transparent PNGs work really well in these sort of scenarios as well. That's tip number 3, I guess. And then when I move the detected image around, it knows, because these other images are anchored just by XYZ coordinates to the initial detected image, it knows it needs to change the orientation of those other images as well, which is kind of neat. And we could take this further. You could actually have anything on there be touch sensitive, so when you touch it does something else, like maybe you touch Twitter and it goes and hit the Twitter API and shows me some tweets from my Twitter account. So that's one. And then what was the other one? Add movie to detected image. So here we go. So on this one, what I'm doing is I'm saying detect out of my business card. When you detect that image, play a video at the location of that detected image. Hopefully the sound's off because it's really. So then when I move that image around that it detected, it will move the actual video that's playing around as well. Again, which is kind of cool. Then the last one for this is adding a 3D model. Got to stop doing that. 3D model to the detected image. So here we're detecting the image again, but this time I'm placing a 3D model onto that detected image. And then when I move the orientation of the detected image, it moves the orientation of the 3D model as well. So because, we're not just limited to one detected image, we can detect hundreds. You could have hundreds of these 3D models, not hundreds, up to 100 in the scene as well. It doesn't always track, as you can tell, but again, caveat being the lighting conditions, etc., etc. Yeah. Okay, so that's image detection. Then, yeah, we've done those. Didn't show the QR codes. Sure, if you go to my YouTube channels, you can watch these videos at your leisure. You can even subscribe to my YouTube channel if you so desire. Then we have got body tracking. Again, all this is built into ARKit. We're not writing that much additional code to create these experiences. We're not referencing external libraries to do this. All this is built into ARKit, okay? Which is, I think, just amazing. Now, body tracking. So what we can do is, when this is running, we can track the major body joints in the body, which, as you can see at this top right image here, which is an image of my daughter who's having a good time. Anything that's green is a major body joint. 1, 2, 3, I forget how many, however many those are. So we can, when I'm detecting those, I'm saying just place a 3D sphere and make it green at those locations. And from those major body joints, it infers minor body joints. It doesn't actually track the minor body joints. It infers their position based on the major ones. So you might think, well, what use cases could there possibly be for this? Well, I've seen a couple, including people doing exercises, so that because you know the location of some body joints in relation to other body joints, doing some maths of angles and distances, you can work out almost the orientation of the body. So you can work out if someone's doing a squat and they're going all the way down, or maybe someone's doing a push-up. I've also seen it used for things like making sure people's posture's correct, because so it can detect the angle from the side anyway, and protect the angle of someone's spine in relation to their hip. And if they're hunched and it's not upright, it can let people know for stuff like that. The other kind of things you can do, which I've not done that much of, is you can get or create your own 3D models and assign different parts of those to the different body joints and almost rig them up. So when you move around, the 3D model skeleton moves around as well. I'll show the use cases for that. So these are the body joints that can be tracked. Like I said, there's quite a lot of them. So you can, once it's tracking a skeleton or a body, you can request and say, right, what's the XYZ coordinates of any of these points, and you'll get them back, and you can do all sorts. Okay, do you have a video for this? I have a video for this. Yeah. The other thing to mention is, it doesn't use the front camera. Sorry, this is because I copied and pasted from the next slide, which is about facial tracking. So ignore that. That's completely false and outright lie. So let's have a look at the video. Okay, I was quite amazed when I got this one. because I couldn't find any C# samples for this. So as you can see, as I move around, it's quite smooth. Again, low lighting conditions in my study, so a bit better lit, this will be even smoother, but as I move around, you can see the major body joints is tracking and the other minor ones that it's inferring as well. It's just me being silly, really. Okay. Right, so that's body tracking. I'm skipping over the code because I think I'm a bit behind and I don't really want to go more than an hour and a half. But there is a website where all this code is on, and I'll show you it later. Okay, so facial tracking. So as well as tracking bodies, you can track faces, which is quite interesting. You can track up to 3 different faces simultaneously, so that if there's myself and my daughter and my son on in a line, we'd be able to track those independently. And when they're detected again, it places a face anchor at the location and keeps track of where it is. So as soon as that event fires, I could say, all right, make this one blue, this one yellow, and this one green. And as we move around, they would stay like that. So we'll mention this is face tracking, not facial recognition. The reason I mention this is because there's been quite a lot of negative press at the moment with sort of governments using facial tracking in ways perhaps they shouldn't be doing. Sorry, facial recognition in perhaps the ways they shouldn't do, and sort of civil liberties being stretched a little bit. So I just want to reassure you, this is facial tracking, not facial recognition. Okay. And this one does start the front camera as when that session starts running. And I do have a video for this as well. Got a boring one and not so boring ones. This is the boring one. When I first got it working, it makes me look like a scary mime and freaked me out a bit when I got it working. It's me saying it's working now. So I didn't actually have to do anything to create that sort of mask effect. That geometry is actually just built in, and it detects the contours of the face. And all I've done is I think that's the default color. I don't even think I set the color to be white. So you might think, well, what's the use of that? What the real world applications of that? Well, we've already seen it. So you need to be able to do this before you and locate the position of the various things on the face before you can place glasses on. So that whole business model of being able to try on spectacles relies on this sort of technology. So at a glance, if it looks like, well, there's not much use for that, actually there is. You might also want to model facial tattoos or something like that, or see what a hat looks like on for you, I don't know. I do know that I've also seen some makeup producers as well, being able to see what sort of makeup looks like applied to different parts of the face. I've seen that sort of use case as well. And then the less boring but more silly example of, it's driving me mad now, of facial tracking is this one, where what I've done is, because I've tracked the face in the scene, tracking, I'm placing 3D models in the scene anchored to my face. So when I move my face around, 3D models move around as well. Idea for an augmented reality advent calendar. So the idea is you could choose different days on the right, and then you'd have a different 3D model appear on the left. And I've got a bit of rotation animation going on the left-hand side there as well. Okay, so that's face tracking. We've done that. Now, as well as face tracking, so there's a face that you can see, built into ARKit, again, sound like a broken record, but built into ARKit is the ability to check different facial expressions. Now, I don't mean angry, envious, that sort of facial expression. They're more emotions, I guess. By facial expressions, what I mean is that someone's corner of the mouth are up, or the eyes are squinting, or someone's winking, or the tongue is out. And there's 52 different facial expressions or contortions that it can detect. And what it does is it can detect those on a floating point scale from 0, whereas the mouth is completely closed, to 1, where the mouth is completely open, for example. And there are some of these that I've not even been able to activate. I don't actually know what mouth shrug upper is. I can do like mouth pucker, mouth funnel, and jaw open and tongue out, but some of these I've not been able to actually be able to fire. I don't know how to contort my face in order to get those sort of events to fire. So I do have a video for that as well. So here you can see it has mapped the contours of the face. This is just like the scary mime example, except I'm using like a mesh overlay rather than a solid color. So let's go look at that sample. Where is it? Sure, I've got this one somewhere. There it is. As it's detecting different things, I've told the mesh to change color so that I think when I'm doing smile or corners up, corners down, eyes wide, mouth funnel, tongue out, cheek puff. So when I'm telling it to detect these things, and I'm saying, if you're fairly sure you're doing these things, so if it's, I think if the confidence is like over 0.5, you're probably trying this thing. So change the color of the mesh. That was quite interesting. And again, you might think, well, what's the use cases of that? Again, you just need to use your imagination. So for example, perhaps you could build an app for someone that people have had strokes and they've got perhaps the side of the face that's paralyzed. Because we've got this ability to test the floating point of 0 to 1, maybe we could, apologies, I'm not medically trained or know a great deal of how strokes work, but perhaps you could maybe try and exercise facial muscles or see over time how much of that facial movement returns over time. So that's one use case I sort of thought for that. Now, as well as placing pretty boring, primitive 3D shapes into the scene, we can also place pre-existing 3D models. Now, our kit supports, or Scene Kit probably more accurately, supports different 3D model type, including a couple that I've got working, which is the Collider format called DAE, and then the .obj format. Now, you can buy some of these or download free ones from places like free3d.com or Sketchfab, or you can even sort of draw your own using a tool like Blender, which is exactly what I've done in these examples. So you can probably tell the difference in quality from the models that professional 3D artists have made, and then the ones that I've made, these football, gone too far, these football shirts here. So my idea for this top left one was, wouldn't it be great if you could have an app and you could show different fantasy football teams with your mates at a pub, and you could just project them onto detect the surface of the pub table maybe, and then you can say, oh, look, do you think this football formation is good with these players and stuff like that. So yeah, I think I've got a video for that. A prototype. Again, I've got no football affiliation or allegiances, by the way, so I'm not a Man United football fan or Liverpool fan. It was just complete coincidence that I decided to use a red football shirt. So anyone who's Liverpool or Man United who's cheering can stop it right now. It's a complete accident. Yeah, so that's quite kind of neat, early example. But 3D modeling is something I want to get more into. Now, this one where I've actually got this sort of terrain 3D model is created using a plugin for Blender. Now, I've mentioned Blender a couple of times. Blender's a very free and very amazing 3D modeling tool. And I found a plugin you can use, and you just go off and call Google Maps if you give it a location. This is a hill walk in the Peak District called Mamtor, and it will generate a 3D model of that terrain. And I was able to save that in a format I could then import into this app. And here you can see how I'm scaling the size, and I've got a bit of rotation going on as well. And I've even got a fake shadow as well projected on underneath, but you can't see that very clearly right now. So that's kind of neat. Yeah, we've done that. Then we've got UI gestures. So it'd be, again, a bit boring if you place items in the scene, but then you can interact with them. So what is built into ARKit and SceneKit, sense of theme here now, is that you can, once you've placed 3D models or objects into your scene, and you're looking at it with your camera and you touch the screen, you can what ARKit or SceneKit can do is to translate that touch and determine if you're actually touching one of the 3D models on the screen. And you can then do things like get it to detect pinches, which is either in or out, rotate, but using sort of this sort of movement, or pan to move things up and down, left or right, or swipe. You know, these people, I think people know what these UI gestures are. So that's quite useful. I've got a couple examples of those as well. So here I'm hitting an API and getting some images, I'm detecting a 2D surface, then I'm creating some 2D planes, creating the images as the material on those. And then I'm using touch detection to detect this pan. So I'm just doing up and down, left, right with my finger on the screen so I can move them around. Then I did a pinch to scale out, then I've done a rotate on that one over here. So that's kind of neat. And you might think, well, what are the use cases of that? Well, one I want to play with is kind of, if you're ever moving house, I don't know if anyone's moved house recently. Sometimes, I don't know if you still get them, but you get like these housing brochures of like the front of the house and the price, and you usually get a few of them, don't you? Because you want to arrange your bookings. You could place them virtually on a table, and then maybe you could swipe them and say, right, that's the maybe pile, that's the definitely no pile, that's the yes, we'll go visit that pile. And then maybe you could touch that, go hit another API, and then maybe you could go from 2D and it could throw up all the internal and external images of that property all around you. So again, you just got to use your imagination to think of the kind of experiences you can create with this sort of stuff. I won't show the boring shape ones because it's just, well, the other one's better. Lighting. So it turns out that AR experiences are better if they look real. And that might sound stupid when you say it out loud, but it's very easy to place an item in a scene and then not consider lighting, which is bad, because if you place an item in the scene in a dark scene, but it looks really light, it looks fake. And if you place an item in the scene, in a really light scene, and it looks dark, then it looks fake. And if you place an item in a scene and everything else around it is casting shadows and it's not, it looks fake. So it turns out that lighting is really important ability because our brain uses light to determine all sorts of things like depth and stuff like that. So what you can do is you can use fake lighting, which sounds odd, and cast fake shadows. And we're going to show how to do that. There's different lighting types, but I don't want to go into them because I struggle to describe them. And to be honest, I don't really know the difference. I usually just use directional lighting. So in this example, what we're doing is placing a cube, sorry, yeah, it is a cube. It's a box that happens to be a cube in a sphere. It's using plane detection, so it's detected the floor. It's placed a transparent plane on the floor, and I've got a fake light source above it, and it's clever enough to know that there's this shape in the way of the floor of this plane, and it's clever enough to know it needs to cast a shadow. And when I move around, it maintains that. So for me, that would look a lot more fake if there was no shadow, and conversely, it looks a lot more real because there is a shadow there. So yeah, that's probably tip number 4. Add shadows to your, probably need a separate slide just for these tips. Add shadows to your experience for a bit more realism, I guess. Because otherwise your brain just doesn't figure out what's going on. Shadow wouldn't even be able to guess how far off the floor it is very well. Okay, then physics. So again, this is from SceneKit, not ARKit, but we can make use of it in our AR experiences. We can, by default, if we place a cube or a sphere into a scene, it doesn't have a rigid shape, but we can make it solid by calling this create kinematic body. I don't know why they can't just call it create solid or make solid or something. And then it's probably some physics term. And then if we want it to just be pulled down, to mimic it being affected by gravity until it hits something else, like something we've made to be solid, we can call this create dynamic body. So again, why couldn't it just be called effect by gravity or something? I don't know. So other things we can do with this physics engine is we can apply force. So we can place an item in a scene, call .apply force method with a value, and then kind of it will just shoot off in a direction. We can also set things like set other variables like some things mass and friction, and that will determine how it interacts with those other items. So I've seen people kind of create sort of mini augmented reality games by sort of shooting spheres out of a cannon in certain directions through those donut shapes and scoring points and stuff like that. So physics is an interesting one. I've probably not used it that much. So if we just move on to the video for this one. So again, what I'm doing here is I'm just placing a 2D plane. Then when I touch the 2D plane on my screen, I'm saying create a cube and make that solid 2, but have this one affect by gravity as it's pulled straight down until it hits this other 2D solid shape. It's not always 100%, and you can tell, go back to my early point about lighting, this is one of my early experiments, so it looks very fake because of the lighting's just, the brain said it's not real. Nothing's that bright, nothing's that color, nothing's, anyway. So if I was to revisit this one, I'd relook at the lighting if I wanted to make it look a bit real. I also don't know why it passes through this 2D plane sometimes, but again, that's just an experiment. What I want to do is kind of build a great big wall of these cubes and then like apply force and just see the whole wall knock down. That would be fun to me. That's how I spend my Saturday afternoon sometimes. Then what else we got? Okay, they're kind of coming towards the end of my talk. I'm conscious I've not showed you many code samples. That's entirely my fault, sorry, but yeah. Okay, so kind of stuff we've not discussed, but it's probably worth mentioning is body occlusion. So what you can do is, just like in the real world, if you place a cube 5 meters away and someone else happens to walk in between your camera and that thing, you would expect the body to occlude that thing because it's in the way. Now, early versions of ARKit, it wouldn't. It would just, you would still be able to see the cube, which is just weird because that body should block it, right? But now, in recent versions of ARKit, it uses body occlusion, which you can turn on, so it will detect that there's a body there and it will occlude it and hide it. So we can also use session persistence so that we can detect all the feature points in a scene, and we can save those and reload those again at a later date. We can also share sessions, which is quite useful because if you, and I've not tried this, but if you go back to sort of the showing the fantasy football example, you know, it'd be really good if when you're viewing, if you're projecting your fantasy football onto the table, if other people could also see the same thing that you're projecting or creating. So you can share sessions, and I believe that's possible. Need to try that out. Then you can do object detection, so as well as face detection, image detection, plane detection. You can also detect objects. So what you can do is you can actually kind of set a scanning mode and scan like a teddy bear, and it will detect the feature points on that teddy bear. And then you can save those, and then you can set it to scanning mode and then move it around the scene, your camera that is. And then when it, if you would move it in front of the teddy bear, it would be like, oh, hang on, I recognize this combination of feature points last time, and it'd be able to detect that object. So that's quite interesting use case as well. You can also use something called constraints, which is good because we can constrain how we want our nodes to behave. It's quite useful. So if we've got 2D planes, for example, we can always tell them to face a certain direction, or always face another node, or always face the camera, in fact. So that's a couple of constraints you can do. And then something else that I've not had a chance to play around with is LiDAR. So newer versions of the iPad Pro have this ability to better scan the environment and almost create a mesh of the environment as you walk around, and then save that as a 3D model and then import it into AR experiences later on. Now, I don't have an expensive iPad, so I've not been able to try that, or iPhone 12, I think it's on. But I do want to try that at some point. Maybe when I'm up for renewal, I'll get an iPhone 12 or something. We've not looked at physically based renderings, so we can make materials on an object look rough or shiny or reflective, or make it look plastic, or make it look a bit different anyway. You can also use cameras. So rather than, how do they work again? So rather than using, I forgot how they work. Mine's gone blank on that. Sorry about that. And then one of the last things I mentioned is that some of this stuff, these AR experiences, become more interesting and useful when you start incorporating other technologies. So for example, if you incorporated real-time signal R, so you could have a socket that's listening in the background, and there, for example, I could create a .NET 4 console application on my laptop that's doing using system.speech namespace to do some voice recognition. And if I said red cube, it could place a red cube in the scene by, again, calling the same signal R and real-time server or something like that. You can use geolocation as well. So one thing you can do is you can say, I've not tried this, I think in newer versions you can say, okay, create a great big massive 3D dinosaur model, but rather than say in my immediate surroundings, set it at these latitude, longitude of the local park or something. And then when I walk along to the local park and look around, I'll see a great big gigantic fake dinosaur. So that's geolocation. And then you can also use, if you wanted, that is, use like the Vision Core ML, which is another framework available on Apple iOS devices. And that's quite clever, because what that can do is and again, you don't have to use this with AR, but you could be good, interesting marriage. But you can look around the scene, and what Vision Core does, it can say, I've got a 99% confidence you're looking at a banana or a car. So you could use that in conjunction with ARKit as well. So that's just some stuff not discussed. Then, as I mentioned earlier, I have a website that I put together that show all these samples, arkit.com. Now, if you do want to play around with this as a .NET developer and C# developer, you'll find that there's not many code samples out there for using ARKit. There's loads of Swift and loads of Objective-C. And one of the first hurdles I had was just trying to translate those code samples into C#. So I've done a lot of the heavy lifting for you. So you should be able to write your C#, base it on the examples I've done. So there you go, you're welcome. And then it also shows the videos as well, and a bit of a description. I call them lessons. They're not really lessons. It's a blurb of my understanding of video and some code. Then again, just to summarize what we've talked about today, we looked at the business of AR. We looked at all the sort of the Lego bricks of augmented reality, all the different things you can do, like plane detection, image detection, some of the things we borrow from SceneKit, like lighting and animations. And yeah, just to emphasize that all you need is a Mac, Visual Studio for Mac, and an iOS device, and you can go away and start trying out this sort of stuff for yourself today. And yeah, watch this space. I think it is a growth market, and you will see an increasing number of use cases for augmented reality. The other thing sort of I mentioned is that I've wrote a book about this, which isn't live yet, and I think it's due for publishing it in May. But all I've done is combine sort of my experiences of this sort of stuff. So there's a chapter on image detection, a chapter on plane detection, chapter on body detection, stuff like that, and the one on how to get set up. So if you're interested in and want to read a bit more about that, there's a book that's going to be imminently available. And other than that, so sort of thank you very much for allowing me to come and speak to you. Do reach out to me if you've got any sort of questions. So with that, I'll wrap up, Sean, if that's okay.
Yeah, sorry, I was muted then. Yeah, thanks a lot, Lee. That was very interesting. And I think that Xamarin ARKit site will be very useful for anyone that wants to dip the toe in the water, at least for start with anyway. So, right, has anyone got any